So my name is Craig Billings. I'm the owner of 3D Extreme. We're a technology and education company. We're located in Baton Rouge, and Extreme stands for Science, Technology, Robotics, Engineering, Art, and Math. And so this is graphic design class, correct? So what we're going to really focus on is the technology and the art. Now, that doesn't mean it's not going to cover a lot, because with 3D printing itself, it can be applied in many different areas. And we just covered all. So why the X? Because we can cover everything. So I don't know. It's just,
there you go.
It's actually crazy how we came up with the name. It was in 2012 when I first found out about 3D printing technology. It's been around since the 80s. Not a lot of people know that. But the patents expired in about 2005, and so you started seeing people kind of get into it and develop machines. And that's when this explosion happened around 2009. And so when I saw it in 2012, being an engineer in design and creating 3D models, I went, oh my gosh, I can actually take what's on the computer and have it in my hand. And I just fell in love with it right then and there. Didn't know anything about it. So when I came up with the idea of the time was just to make things like figurines to sell from custom wedding toppers and stuff like that. And so I got into it and got into the technology, and actually had a partnership. And it didn't turn out so well, but what we learned together was the technology and building our own 3D printers. We would build the machines. And so that took a while to figure that science of it out. And this is our newest one, the GoBot, really small, kind of compact. And we combine it together in education with our online learning platform that you guys get to mess with. We'll give you a free account so y'all can set up and get to learn about it. And so this is our newest model. We do have bigger ones, and we're actually changing some of that stuff up. But our main focus with education is in the stream method. You probably know all about STEM. We just added the robotics and art to kind of break it up a little bit more. So I'm going to really focus today on kind of going through the PowerPoint really fast, because I'm sure, do y'all really know a lot about 3D printing at all?
Not much.
Okay. I won't hang up on the technical aspects, because I can chase that rabbit so far. But you know, as a caveat, I'm from across the other side of the river in Plaquemine, so if you don't understand what I say, if I talk too fast, just stop me. Won't offend me. My wife does it all the time, slaps me and say, what? So she's from Gonzales, so we're worlds apart. So just to let you know.
My husband's from across the river.
Yeah, we talk funny.
Yeah.
Sometimes we don't understand ourselves. So.
Yeah, and it's very fast.
Yes. So if I say terms that you don't understand, just say, hey, what is that? Because I've been so far deep into this technology, I've gotten accustomed to saying things that people don't know what I'm talking about. So hopefully I'm going to go through some of these things, the technical stuff, really quick, and we'll get to more like why we're here and how I can help you. And I'm going to kind of follow your flow to see where we're going to end up. And that's kind of how this is going to go. So some of my fonts aren't showing up because I plugged it in my USB. It's okay. So if it looks so funny. So this is what we're going to cover, the basics of it.
So one second, guys,
Yep.
interaction here, okay?
Yeah, that's fine. Ask questions, throw something. Not the puzzles, they hurt.
Yeah. Not throw.
So this is actually one of the lessons that's on our website, 3D Printing 101. And this is some of the assessments we have for each one of our websites. We have an assessment, so you actually get tested on what you've been taught. And this is the vocabulary for this one. We're switching some of these things up, so like I'm up here presenting, so the class will be that in the future, along with the PowerPoint slides. So if you see vocabulary terms in the line, that's what that's about. There is an assessment, and there's going to be a quiz after this one. I'm kidding.
Everybody freaks out.
Yeah.
My heart dropped a little bit.
So what is 3D printing? It's a process to take your idea and make a real-life object. So you have an idea, you draw it on a computer, you send it to the 3D printer, the printer builds it, and then it becomes that, a real-life object. In essence, it's just taking something conceptual design and bring it to life. So what is a 3D printer? Just like, you know, a 2D printer is paper printer. Well, you add that third axis, that Z-axis, where it goes up and down. That creates that depth. In graphic design, most of the models, in like Illustrator, I'm pretty sure, I don't want to speak too much about Adobe because I don't know a whole lot about those things, but there are a lot of 2D concepts. You know, just the flat models. Even though they may look 3D, even gaming, a lot of those models are not necessarily 3D. It's kind of tricky. It looks 3D. But in the real world dimension, that third Z height, X and Y, left and right, which is this. We call this X and Y. X. This is Y. And when this goes up and down, that gives you the Z. So just an instance. And the extruder is the print head. So if you ever hear extruder, that's that terminology that will be used. And if you see the underline things, that's because that's part of the vocabulary. So it kind of points back to, hey, pay attention to this. So what happens is this plastic is fed through the extruder. It gets heated up. You can't really see all the components in there. It goes through a hot tube where the motor drives it cold, and it goes through a hot tube, and it comes out really tiny onto a flat surface called the print bed. Now, in essence, it's like a hot glue gun, just really, really fun. It's actually a gas nozzle at 0.4 millimeter, and you can get different nozzles. I won't go into that because that changes a lot. But the standard is 0.4 millimeter, and so that's really, really tiny, like human hair tiny. I wouldn't know about that, but I'm just saying.
Yeah, so what's the most commonly used material?
We're going to get into that.
Okay.
Yep,
Okay.
that's on the slide. Good question. So how do you use it? The first step is you have to have the 3D model. Now, I'm probably going to stick a lot and stop on 3D model a lot because that has a lot to do with graphic design, and you can't even get to 3D printing without 3D modeling. But you can actually stop at 3D modeling and have nothing to do with 3D printing and have a whole world open to you. So that's kind of why I love 3D printing. I use it. It's great. You can start a business with it. A lot of businesses use it. But 3D modeling gives you so much more opportunities in the world. So the first step is design it. Now this is actual shown from Tinkercad. It's a free software that's out there developed by the people who made AutoCAD, Autodesk. It's really cool. It seems kind of blocky and kiddie at first when you first see it, but I've actually started falling in love with it as far as the text. You can do like really cool text and 3D text. And Tinkercad, rather than AutoCAD, which is more like precise engineering type of stuff, you can still do it, and I used to use it. As a matter of fact, I made this logo in AutoCAD, which you actually see right here, and I printed it out with our big printer that does 2 colors. So you can use it in graphic design for custom logos, things like that. So it's an idea. Now, we'll ask you at the end of this about some ideas maybe while we're speaking that you had, how you can apply 3D printing in graphic design. So if you can write those down, I'm hoping to get feedback that I actually open your minds up is what I'm looking for on how you can actually use it in this class. And even beyond, but mainly in this class. So the file type, this is important for 3D printing, is STL and OBJ. I really stick to the STL. That basically means the dot at the end of a file type, like a .txt file, will not work. The .stl is the export of the file that you need when you're exporting from 3D print. And CAD, if you ever hear CAD, and I'll say that again, it's computer-aided drafting. You'll hear that in the drafting and design class and anything that has to do with like engineering. Where's your CAD model? So, oh yeah, I drew that there too. So the second part is in the software that comes with 3D printing. It's called slicing the model. So you have this model you created, and it's like, well, how does that go to the 3D printer? Well, it takes that model and breaks it down into each layer. So you take away the Z, and now it just has that X and Y, like a piece of paper stacking on top of each other, and that's what you see it. And it's called slicing, that process. So anytime you get into the programs like that comes with any 3D printer, you hear slicing, like Cura Slicer is a popular one, Repetier, Slicer and Repetier. Those are the 2 most popular slicers. And different manufacturers make their own. We actually took free software, customized it, and had it customized, and it goes with ours, and it's all ready to go in a package, all the settings and everything. So the last step is, of course, is to 3D print. Now, the term 3D printing throws everybody off. It really is more of, it's called additive manufacturing. Anybody know what a CNC machine is? So it cuts things. It's a router, it moves on 2 axes. That's subtractive. So 3D printing is part of additive, where you're just adding multiple layers on top of each other. So that's kind of what that is, and that's showing you how it kind of builds here a little bit. So here's some of the applications. Now, the main 2 uses for 3D printing, more than anything, is product development and prototyping. So making custom objects. This is an example. This is a car for Exxon Mobil that we actually had a 3D printer over at their facility just opened to show the new plastics plant. And this was on the printer printing so people can actually see, since Exxon does plastics, how that actually works. So even car designers, manufacturers get to develop their products, print it out, look at it maybe, and it saves you thousands and thousands of dollars. It's a little bit smaller, of course. I mean, people have 3D printed a car, but I don't have the time because it is a slow process. But the great thing about 3D printing is you're not doing it, the machine's doing it.
Yeah, I know we passed the programming part.
That's fine, we'll get to it.
As you said there's a free one.
Yep.
How much would you say like a costly one would be about?
For 3D modeling, I like AutoCAD, but it's $5,000.
Okay, that's what I was
But
asking.
they do have a new model, subscription method model, to where actually for you guys it's free. anything Autodesk makes, you get a student account for every one of their softwares. 3ds Max, which is animation, Rivet, which is architecture and design, Structural, which is for structural steel. I mean, you name it, they give you free access for 3 years, and then if you're a student, you sign up again.
Wait, that's for the Autodesk?
Autodesk. Autodesk makes a whole suite. If you look on the Autodesk site, they make so many things. They just started scooping up a lot of different companies, and they make some really cool stuff. So even on websites like Instructables, which is a do-it-yourself type of website, if you don't know it, it's really cool. I use it all the time. It's people put up their ideas like DIY stuff. They own that too. But Tinkercad is also owned by Autodesk, and it's free. It's a good place to start. We have lessons, and they're free for you to go on our website and go look at, and you can download Tinkercad at home. It's cloud-based, so that's a really good place to start. Now, like I said, I've actually started. It's really great for like characters, which people are really difficult. People and animals are the two hardest things I've ever come across that I had to do, and I can do them in AutoCAD, but Tinkercad is a really cool way to do it. So just remember that to frame 3D printing around those two uses. Now in education, we kind of did the same thing. We just kind of put the models ready to use. But outside in the business world, those are the two things people are using it for, custom objects. Because a lot of people say, well, I can 3D print a plastic paperclip. I'm like, why would you? You can buy them so cheap. That's not what it's made for. So there's a aspect of practicality when you're using 3D printing. And some of the other things that include architecture. This is one of our lesson plans. And I didn't bring it because I actually dropped it, and it looks bad. But it's a state capitol building, and there's a history lesson that goes with it that they learn in history class, plus you get to put it together in pieces. This is actually a working crescent wrench.
Really?
Yep, and so there's a lot of models. You can keep them here, it's okay. So there are a lot of models that, and some of them you can download online, like this one we didn't create. I'll get into that. Another one is automotive and aerospace. So this is a 3D model that actually GE put out to show compression engines for jets to show you how it works. And so they put it out, and we downloaded it and said, oh, that's really cool. So, and they actually do metal 3D print some of their components. I think this last, I put it on the Facebook page. I forgot how many parts, but hundreds of parts were 3D printed for the last plane that flew.
Oh,
Metal,
Wow.
not plastic, but
yeah.
I don't know if I find
So
something
that's probably
plastic.
a different procedure than if it's metal.
There are many different procedures. That's a good point, because what we're going to cover and what you have in your classroom is fused filament fabrication, FFF. I can't use the other term because it's copyrighted and I'll get in trouble, but FFF. It means that it takes this plastic, and I'll take it off in a second when we get to it. That's the most cost-effective method. There are many, many methods, but yeah, you're right. There are different types. And this is all polymers, plastics, that I'm going to be discussing. There is some new machines out there that are like this that kind of do metal. I haven't touched them yet, and they have patents on them because, you know, whatever, but I hadn't gotten to that. So this is another thing that I was going to show you, if I can find my models. Oh,
Oh, look, you can use some high heel shoes.
you can. So, but to show you, I modeled those in AutoCAD. I did those in there right here. So,
High heels.
so here's something, some lady contacted us a few years ago and wanted to make, she saw pictures online from like, oh gosh, World War II era and before, on Roman era, and saw these pictures of rings online. And she said, can you make these? I was like, I can draw anything, but can it print? That's the $1 million question. Well, it did. So what she did is we did some modeling work for her, 3D modeling work. We had these customized. Be very careful, because this, and I'll actually tell you that different process. She took these plastic molds, had them converted, and so it may have cost her some money, and it did. Hey, you can just look at them. But she sells them now for a few $100s each. So,
Wow.
so we did the
So
3D modeling work.
Demos or?
Those are examples of the 3D printed rings that from the CAD model we did. She has them lost wax, what they call it, and they're actually metal. So she takes them and makes a mold from that. So just be real careful because they are gentle.
She used these as a mold.
As a mold, and that disappeared. So basically the metal took over that part in some type of foam, so ceramics. So that's really cool about,
Let me see yours.
it's really neat. Some of them are in 2 pieces.
Are these metal?
No, those are,
No.
don't try to squish those.
Yeah.
No,
no.
But that is a different process of 3D printing. That is not this
So what is
process.
this?
That is some type of plastic. It is, but it's not this.
No, because it's very thin.
Correct. It was done with powder type 3D print. It's very, very expensive. And the only reason I show it is to show that just the 3D model and aspect alone, you can make a lot of money.
It's very detailed too.
It's extremely
You know
detailed.
what I'm saying?
That's the finest I can get that a 3D printer could do.
So why would you use the powder one over the normal one.
So-
or something like this.
The answer to that is this. That's how small it comes out. And if you feel that, it cracks and breaks in your hand.
Right.
So it's a different process of fusing how the materials are fused together. So if you remember earlier, I talked about layer upon layer upon layer. Let me see if I have something here. These are pretty thin. I'm trying to, oh, maybe you can see it inside of here. So you can look inside of here and see the patterns, and we'll get into that. But the thing about that layer upon layer, it does fuse them, but there is some, they're pretty strong. I mean, these things are kind of tough to break,
Yeah.
depending on how you make it. But it's just a different process altogether is how it works. The powder stuff, at that, what is it, thinness, size,
Yeah, you
is
get-
stronger than doing just a
So
plastic.
like for tiny models, that's like the type
That
of,
process is probably something you would
That's like
use.
the best
And I don't have that type, that printer alone is probably $56,000 just to buy. The material is $600 per roll compared
so
to
like
12.
each different type of like filament or whatever it is that
Process.
you use requires
A different type of
printer.
media, yep,
Wow.
yep. So, depends on what you want to do. And there are some that use fluids called laser sintering, and that's like extremely fine detail, and architects typically use that stuff to do their display models. That resolution, you can't see the,
Oh, you
illus-
can't
you
see
can't
the-
see it. It's extremely expensive, the material.
Yeah.
And health and medical. So here's a model of a human heart, so you get to actually see what's inside, and a lot of now what you see going on is the medical industry is starting to 3D print things out there.
That's gotta be expensive.
Yep. Yeah. So they're 3D printing things in the medical industry and actually doing surgery, practicing on these things before they get into a patient with really delicate stuff. So if they mess up, you just throw the plastic away. But this is actually working prosthetic for someone who's missing fingers. They would put the cables in, strap it on their arm, and it helps them grip when they put it in there. Looks kind of Terminator-ish, but
Yeah.
yeah, I think as a how would I say this? I messed it up, and I just said I'm just gonna put this together, show people. So it's probably
Yeah.
I even hot glued it. I said, look, it's not. It's just for show. So that's just shows that in the medical industry they are using this technology as well. But what we're going to focus on is how you can use this in education, and we use that method, and we use 3D printing at the core to kind of feed those. So it's more for cross-curricular type stuff. So here's the answer to your question. I'll turn this around so you can see it. So, and I didn't show you, but in the education, you can also make robotics. And what's really cool, except for this part and this part, we use a lot of these components in our 3D printer. I didn't finish this. I was just showing that you can actually make robotic arms, and you can actually learn programming, how to program things with 3D printing.
Imagine making a 3D printer with a 3D printer.
Oh,
Actually,
yeah, right?
we do have one.
No way.
Mhm.
Are you serious?
Hmm. So here's
Really small.
so here's another thing in
pretty good.
fashion. This is actually
Sub-Zero.
Sub-Zero's mask.
The one right there, in the back, the extruder was completely made out of 3D
Yep.
printed material.
I think we might have a part on that one, but we do have a printer that I kind of shelved it for DIY people if they wanted to kind of have all 3D printing files and make their own. That's the cheapest way I figure I can sell something to get people interested in the parts. But I kind of shelved it because I've been focusing on other things. But you can 3D print parts. As a matter of fact, our big 3D printer, a lot of the components on are 3D printed. The stuff that you can't make. That's the thing about 3D printing. It's things that you can't make by any other means or processes. So we have these parts that had all these, that would hold a motor, hold rods in, hold a belt, hold a gear. It didn't exist, so I made something that existed. So that's really cool about 3D print. And of course it took a little while, but I mean it cost $1 in parts to make it. So this is an art kind of thing. You can light it up, and it's a Christmas ornament. Found online, I didn't make it, but just to show you. And here's another cool little art project. This was actually done in pieces, and I took the part off. It was done in white and done in multiple parts and was painted. So you can do kind of custom pieces like that. And this is just our mascot. We call him Switch, just to show people the different colors we had, and that's kind of our thing, like to see. And I did that in AutoCAD. And yeah, actually, should have did it in Tinkercad. I think it would have been easier. But so to answer your question about the materials, so there are bigger rolls I don't have any bigger rolls, but this is the little printer, so this is probably a quarter of the size that normally comes in. But they come in about 2-pound rolls, typically on average. Like for that printer, you'd see those rolls that you have. This is a quarter the size since it's a smaller machine. And we call it filament. So if you hear filament, you'll see that a lot. You find it on Amazon anywhere. We do sell it. Right now, we don't make our own. We just resell it. So you can find it on Amazon. Except for this, you can't find that on Amazon for this machine. So one roll of normal material, this is what you can make. 200 keychains, 58 iPhone cases, or 103 chess pieces. Now, you take a quarter of that, and that's what you can make of these. So you could probably make 35 of those robots out of this roll. This roll costs about $12. So if you do the math, it's a very cheap method to use. So that helps you if you're trying to use things in 3D printing in schools to actually make money and do fundraisers and things like that. So that helps. A lot of people do that. The most common types, PLA, number 1, polylactic acid. This is the most common type that you'll see in 3D printing. And this 3D printer, the small one that we have, only does that. Because I, 99.999% of the time, am only using PLA. Even with my big printer, I can do other things. I just find it easier. I find it does what I need. And the other type is ABS. ABS, we'll get into. I'll tell you more about it. But there are plenty of types you can get into. The nylons, the flexibles, and dissolvable material that I've been testing. It's kind of tricky. PLA is a biodegradable plastic. It's fairly new. So it does melt at a little bit lower point than ABS, and it does not stink. It does smell a little bit, but it doesn't stink. So it's pretty harmless. It's harder, which means a lot of people say it breaks faster since it's harder, and it's true. But I like it, and that's actually the 3D model of PLA that you can do without a lesson plan. Legos, ABS. So now people can understand what ABS is. I can't say that, but that's what ABS is. I always have trouble, so I'm not even going to attempt it. So Legos are basically made from ABS. So next time you step on a Lego, dang you ABS.
And dang you,
Yes, right.
system.
So it does withstand heat a little bit more and can stand a little bit more friction. What's really cool about why I put ABS and acetone is because our very first 3D printer we built out of plastic. So if you take fingernail polish remover, acetone, and rub ABS together and hold it for a minute, it absolutely welds it together and almost permanent. So it's kind of really neat. It's dangerous if you don't with the proper protection equipment, but it's really cool. And it does have a very, very strong odor. Anytime I 3D print with it, I have to get away, turn the air on, and get out because I get nauseous. So that's why I tell schools, use PLA. It's on you if you use ABS. I'm just giving you a warning. And it does have some toxicity with it. In a room like this, you'd probably be okay. But, in apartments and stuff like that, not a good idea. So that's pretty much it.